Hello Gators, this is 10-3, day 1. I can relate the length of a chord to its central angle and the arc it intercepts. Let's take a look at these two triangles. Notice that they are made up of radii, so this side and this side are congruent. And this is 3, so this side and this side. So we have 4 sides that are congruent. We also have an angle between. So these two triangles are going to be congruent by side angle side. And once the triangles are congruent, we can get their corresponding parts. Corresponding parts of congruent triangles are congruent. And we can get BC to equal EF. And therefore, that will be 5.27. This is a similar situation. These two triangles have all these sides in common because they're radii. And they also have vertical angles congruent. So the triangles will be congruent by SAS. Here's the letter order. Therefore, RS will be congruent to UT by CPCTC. This is leading to a theorem that we'll have in a few minutes. In a circle, if central angles are congruent, then the chords are congruent. Let's take a look at this circle where the chords are congruent. So we have chords that are congruent. Let's see what else we can find out. Now we know these are all radii. So these two triangles will be congruent by SSS. So triangle ABC will be congruent to triangle ADE. And I'm going to call this angle 1 and angle 2. Therefore, angle 1 will be congruent to angle 2 by corresponding parts of congruent triangles are congruent. So now we're seeing that when the chords are congruent, then the central angles are congruent. They have the same measure, so they'll be congruent to each other. And here's the theorem. So if chords are congruent, then central angles are congruent. If central angles are congruent, then the chords are congruent. It has all to do with congruent triangles. Let's take a look at doing this problem. Notice that we have a circle and we have chords congruent. So these chords are congruent. So that tells us these two angles will be congruent. So central angles are congruent, which is going to allow us to make these measures the same. 120 equal to 3x minus 60. So this is going to be 180 is equal to 3x. Therefore, x is equal to 60. Now we have central angles that are congruent. Right here we have some angles that are congruent here. And once the angles are congruent, we know that the chords are congruent. So that means I can set 5x minus 6 equal to 24. So 5x equals 30, and therefore x is equal to 6. So let's take a look at a new theorem. If arcs are congruent, so now we're going to be working with arcs, these arcs right here. If arcs are congruent, we're going to prove that chords are congruent. And if chords are congruent, then arcs are congruent. Let's see why. Okay, so these arcs are congruent right here. This arc and this arc are congruent. And these arcs, and if we go ahead and draw these radii, it's going to create some triangles. And if these arcs are congruent, remember the theorem we just proved, these angles are congruent. And once these angles are congruent, we can get the triangles. Once these arcs are congruent, then we know the chords are congruent by the theorem we just talked about. All right, so let's take a look at this. We have some chords are congruent, and so this refers to the arc measure, how long this arc is and how long this arc is right here. So then we know the arcs are congruent. So we're going to set these two equal to each other. And I am going to subtract 2x on both sides. And then I'm going to add 83 to both sides, so that's going to be 98. So x will be equal to 98. Let's take a look at this. We are looking at for some arcs that are congruent. Let's see if we can find some arcs that are congruent. Well, this arc right here is 109 degrees, and not 109, 119 degrees. And this arc right here is also 119 degrees, 119 degrees. This one is 119 degrees. So if the arcs are congruent, then because they have the same measure, they are going to be congruent in the same circle. Therefore, the chords are congruent. And the chords we're looking at are AC. That's cutting off one of the arcs, is congruent to FD because that's cutting off another one of the arcs that we want to work with. Okay, so what we worked with today is central angles and chords and arcs.